Hey guys, I'm going to show you how to turn on a cooling fan, engine cooling fan here. Soft started and also control the speed so it's somewhat pulse width modulated. We'll use a MS3 here for demonstration purposes. Coming to Tuna Studio, it's fairly simple, the setup here. You can go down into programmable pulse width modulated outputs, and here you can set up a table. You can choose whatever you want, vehicle speed, RPM, coolant temp going up here, and then you can plot in what kind of duty cycle you want the fan to run. One of the interesting things I ran into when setting this up is the frequency portion of it. Your options here on Tuna Studio are all very low in terms of driving a motor. And you'll see what I mean by this in a second. I'll actually hook this up and demonstrate it here and let you see. The highest frequency you can get to here is 250 Hertz, which is incredibly slow for driving a motor. It's going to create a loud hum, a buzzing sound, and it's not very efficient at driving the fan. You'll see at certain lower speeds, for example, the fan won't even turn. And I've run something like this over a period of years on some other vehicles, and that pulsing action eventually damages the shaft where the blade attaches, so it's not a real clean way to go. But this does form the basis for the fix and the correct way to do it that I'm going to show you shortly. Now the MS3, it has pretty low current sinking on its negative pulse width modulated terminal, and what I mean by negative is it's grounding. It's providing a pulse width ground, not a positive power. So what we're going to use here is a solid state relay, and this will take the pulse width modulated signal and provide the higher current that we can use to drive the fan. Alright, so let me get that wired up and we'll carry on. Alright, so we got the fan hooked up here. It's just the temporary hookup. We got the solid state relay. We have a meter here so we can just kind of see what voltages are going on. Hooked up to a car battery just for a temporary setup to power this. And the MS3 again will be providing the pulse width signal to the relay. So we go in here. Advanced setup, generic programmable output A, and it's now connected, so you can see it highlights what cell we're in, so that makes it easy enough. The higher the frequency you go, the quieter the hum, the less of an issue it is. So we'll go straight to the highest frequency, which will be the quietest amount. And let's start out with just 10%. You hear that noise? And it's not even able to drive the fan at 10%. You can certainly hear the motor. It's pushing, what's that, about 151 millivolts. It's not really even seen a voltage with it working like that. So let's go ahead and move that up to 25% duty cycle, and you can hear the sound change. It's actually driving the fan now, but you can hear that hum. 2.5 volts it seems. %. Listen to that. It sounds awful. $75. It's finally sort of reaching the point where the fan sound overcomes the hum of the motor, but you still hear that motor humming. %, and now we're pretty much just hearing the fan. As I mentioned, the problem is that frequency. It's just driving it way too slow. So what you can do is you can build your own controller, something Arduino based, to take the pulse width signal from the Megasquirt, Holly, whatever you've got, and turn it into a higher frequency. You need to be around 20,000 hertz or 19 or 20 kilohertz to drive it effectively. An easier solution I've found is something like this. It's a controller. This particular one, let's see if we get some light on here. It comes out of a Ford Fusion. There's a variety of vehicles that have them, including there's a GM version of this as well. I saw in like the C6 Vets, possibly others. This was also in the Lincoln Zephyr, the Mercury Milan, and a few other vehicles. But this controller, what's nice about it is that it takes a pulse width signal into it, and it doesn't matter what frequency you're putting in, it always outputs 19.2 kilohertz is what I was measuring it at. And that fixes all the noise with the fan, and it also allows you to drive it at slowest speeds without any issues. It's quite an improvement over just using a solid state relay directly from the Megasquirt. Let me get this wired in and I'll demonstrate. Okay, I have one of these controllers now wired up to the fan, and the solid state relay is being pulled out of the picture. The MS3 will pulse width modulate it directly. So let's go up here. And as before, we're going to start and try to do 10%. There's a small delay as it has a soft turn on. And look at that, just 10%, and the fan's just as quiet as can be and just gently pulling air. And look at the voltage, you can see how much higher it is too. 3.7 it's showing. And that's because the frequency's been picked up. Let's see, is it on there? About 19.5. It seems to hover. I've been checking it. I get 19.2, 19.5, somewhere around there on the scope. So we can turn that up now. Jump to say 25. And I don't know if you heard, there's the little delay there. It like just slowly ramps it up. It's 25%. $50%. There it goes. $75. Can you hear it picking up? 90. Something else nice, even if you had to jump straight to a hot temperature, you won't deal with that harsh spike of when the fan speeds up. Sometimes your RPM can stumble on the car a little as you get that immense voltage spike or dip and then spike back up, and you also get that load on the engine right as it snaps on, especially if you're running a really powerful fan, a Mach 8 fan or aftermarket fan. So I can go straight to 90, and before I hit the key here, as you can see, I'll tap the key and I'll turn to the fan, and you can watch the delay and how it ramps up instead of just snapping on harshly. So let's go 3, 2, 1, key was hit. Set it back to 0, and you can actually hear it phase down. Although rapidly, you can actually hear the controller going to different speeds on the way down. It didn't just cut power to it. You might have noticed I went to 90 as the highest, and the reason for that is in my testing with this controller, 90% provides maximum output to the fan. Anything over 90 does not improve the speed of the fan, but more importantly, I noticed when I got up higher, like about 97, 98% duty cycle, it would actually switch its output off and the fan would just shut off. I don't know why it's designed that way, but it's good to know so that when you're setting up this table, you don't ever want to put 100%, because that would be where you're at your hottest and you want maximum fan and you're going to get no fan. 10% was the lowest that turned on the fan. Anything below 10% duty cycle did nothing. The fan just sat off. So your range is 10 to 90%. Those controllers are really cheap. Find them in the junkyard. They work amazing. Hope that helps you guys out. Bye.